All right, we're back with video number 6. Talking about the Outdoor Economic Impact Toolkit from the Building Outdoor Communities program, and this is John Whitehead. Okay, so we are talking about recreation economics from the Loomis and Walsh book, and this topic is benefit transfer, or as the chapter calls it, other valuation methods. And I've changed this wording to other valuation methods because there's more than benefit transfer in this chapter. So apologies for all the slides that said benefit transfer on the previous videos. Okay, so the readings from this chapter are pages 176 and then bounce up to 179 through 185 and then skip over to 189 to 191. Okay, so we'll talk about benefit transfer, which is a shortcut method that doesn't require site-specific data collection, and it doesn't require statistical analysis. Okay, if you have an estimate of the number of visitors, then you can use these methods to estimate the value of a recreation site. Okay, so the chapter talks about unit day values, U.S. Forest Service values, and benefit transfer. We're going to totally skip unit day values. And the U.S. Forest Service values, these are unit day values developed by the U.S. Forest Service. Okay, and in the topic of benefit transfer, we'll talk about benefit function transfer and meta-analysis. Okay, and then we'll talk about what the book calls hybrid approaches, where you combine the approaches of the travel cost method and the contingent valuation method, and these can also be called contingent behavior approaches. Okay, so benefit transfer in general is the adoption of values from other studies when there are time and budget constraints, when you don't have the time or the money to develop an estimate of the value, the economic value of a recreation site or recreation activity that is subject to your study. So there's 3 approaches, and they go from the simplest to the most difficult or the most complicated: unit transfer, benefit function transfer, and then meta-analysis. And we won't talk about meta-analysis from this chapter, but there's a paragraph or 2 in the readings, and you can take a look at that to get a feel for what that approach involves. In terms of unit transfer, okay, let's talk about the U.S. Forest Service outdoor recreation values. Okay, so U.S. Forest Service has been developing unit day values for recreation since the 1970s. And these tend to come out every 5 years, and here's the August 2017 report. And Table 2 in that report presents summary statistics for average recreation economic value estimates of consumer surplus per primary activity day per person. And these were developed from recreation demand studies that were dated 1958 to 2015. And so you see in this first column, we've got a number of outdoor recreation activities. The next column tells us the number of studies, the number of estimates, the mean or the average value of those estimates, then the median, which is the median is the number for which 1/2 is above and 1/2 is below, and then the standard error of the mean, which is a measure of the statistical precision of the mean estimate. And then we have the minimum and the maximum of those consumer surplus estimates. So in terms of the number of studies, you see that fishing and hunting are the most common activities in the recreation economics value literature. Okay, and for those, let's say the mean value estimate, if you were to estimate, we're trying to estimate the value of recreational fishing opportunities per person per day, you could use this estimate of $73 and multiply that by the number of fishing days over the course of a season or a year to develop the total or the aggregate economic value of that activity. And you could do similar things with all of these estimates. So the highest value, non-motorized boating, okay, a recreation day per person is the consumer surplus or willingness to pay for that day is $114. Biking is $99. And the lowest value is backpacking at $17 per day. But notice this estimate was developed from only 6 studies with 41 value estimates. Okay, so table 3 from that report breaks those estimates down by Forest Service regions. So let's say that you want to estimate a unit day value from a study site, which are all these Forest Service regions, to some policy site. Then where the policy site is in Western North Carolina. So since accuracy of these transferred estimates depends on the similarity between the sites, you would choose the Forest Service region that matches up to the policy site. And this table doesn't show it, but since there are lower sample sizes across regions, then the standard error of the estimate is going to be larger and there's going to be less precision of these estimates. So that is another thing to take into account. Okay, well, benefit function transfer is a little bit more complicated. Okay, transferring from a study site to a policy site, study site where you have an estimate, policy site where you don't have an estimate. Accuracy can also depend on how different those areas are. Okay, so benefit function transfer might take account of that. You might have a travel cost method or contingent valuation method demand function from a study site. And let's say income is different between the study site and the policy site. You could plug in income values into the demand function from the study site to adjust the economic value estimate for the policy site with the local income levels. Okay, and where those two areas are different, benefit function transfer might be more accurate. So then meta-analysis is an attempt to develop a benefit function with all of the studies that you can collect. So the idea is to correlate study characteristics and locational characteristics with the economic value estimate across a number of studies to develop a benefit function that can be used. And that's all we'll say about meta-analysis, since that's beyond the scope of this study. Okay, so in terms of hybrid approaches, there are maybe 2 types called trip response. One is the trip response model, and the other is contingent valuation. Okay, with the trip response model, survey respondents would be asked how their trip-taking behavior would change if recreation quality or prices change or if something else changes. So here, going back to the travel cost method chapter, here's figure 9.4, where they talked about a shift in demand in a demand curve with an improvement in quality. So the idea would be that the demand with current quality would be estimated with the actual number of recreation trips that people tell you that they would take, and then you might describe a change in quality or improved quality at the recreation sites, and people would then tell you how many trips they would take with the current travel cost and the new quality, and that number of trips is greater, and so you get a new demand curve, and so the gain in consumer surplus would be this shaded in area. Okay, and then the second hybrid approach is related to the contingent valuation method that we talked about in the previous video. Okay, so you might ask questions like, do you currently visit the recreation site? And those who are currently visiting the site, you ask if the cost of visiting the site were Y dollars higher, would you still visit? So that's the contingent valuation question that we talked about in the last video. And then for people who say they would not visit the site if the cost was higher, you could ask, would you visit the site if quality were improved by X, where X is some description of a quality improvement. And then going back to question A, for people who do not visit the site, you could ask question C, would you visit the site if quality were improved by X? And there's all sorts of variations in these three questions that you could use. Okay, and so the type of data that you get, this is figure what allows you to estimate this second logic curve that we talked about in the last video. Okay, so since the average willingness to pay is the area under the logic curve under current conditions, this curve to the left, okay, if you asked for X, this change in quality is a doubling of the chances for bagging a trophy elk. And in that case, the value of the recreation trip might increase, and you'd estimate this second demand line to the right. Okay, the one with circles instead of squares. And then the value of that quality improvement is the area between these two logic curves. And that concludes the range of valuation approaches that we can use in the Building Outdoor Communities program for developing benefit estimates of outdoor recreation. And then the next and final video looks at how these estimates might be used in benefit cost analysis.